Here we're looking at misleading graphs, studies, and statistics. So just remember to be aware, or if you want to shorten that up, you can beware because these things are out there. So when seeing any graph, chart, or study online, always be skeptical at first and look for these tactics with these graphs. So first of all is the axis too zoomed in, either the Y or the X axis. Second one, does the y-axis start at 0? When the y-axis doesn't start at 0, it starts much further up or down. It can give a very misleading impression of what the actual data looks like. Third thing you can ask, especially if it's a study, poll, or survey, is the sample biased? If there's a poll taken at the Blazer game about who's your favorite NBA team, well, that is going to be a biased poll because most of the fans you can assume at the game are Blazer fans. Fourth thing you should look at is, again, this would be with surveys or studies or polls. What is the sample size? So how many people did they survey, poll, or were part of the sample? Because if it's too small, you really can get nothing from that data and make no conclusion. The larger the sample, the better. Again, usually you want samples with quality data in the thousands or even tens of thousands. Samples with 10, 20 people, you really can't take too much from. Fifth thing to look for, correlation versus causation. Just because two things correlate does not mean that there is any link between the two, and you can also mess with the axes of both to really make it look like a correlation here is happening. But correlation versus causation is up to you to decide if the two things are linked or not. Sixth thing, a cherry-picked timeline. So when you are looking at data, it's very easy for whoever is displaying the data to cherry pick a period of time that makes whatever they're trying to have you see look good or bad, depending on that. So it's always good to have an idea to zoom out and look at the whole picture and make sure you're not just getting a very cherry picked portion of what they want you to see. And then finally, for all of these, you always want to ask, what is the source, no matter what, where you found it. You want to ask, first, where's the source that you found it? Is it credible? Second, what source are they using? So usually there's two sources involved. First, it's who did you find it from or where did you find it? And second, what is the second source or the primary source that they're displaying? So again, always be skeptical and look for these tactics. So when you are looking at these first two, is the axis too zoomed in and does the y-axis start at 0? These two are going to be very common tactics used for line graphs, bar graphs, and histograms. So whenever you can encounter a bar graph, line graph, or histogram, always be aware of the axes and if they're too zoomed in, and especially if the y-axis starts at 0 or not. For these two, is the sample biased and what is the sample size? Those are going to be very common in polls, surveys, and studies. So anytime you see poll show or survey says or a study may show, you always want to ask these two questions. One, is the sample biased? So who's doing the polling and who did they poll? And then two, what is the sample size, aka how many people were involved in the study or how many people were involved in the poll or survey? And if it's not very many, take it with a grain of salt. Correlation versus causation. This is going to be a very common tactic in line graphs and dot plots whenever they're trying to compare two different variables and see if they correlate with one another. Again, line graph and dot plots are going to be most common for this. So it's up to you to always decide, is this correlation valid or is it random or is something being manipulated to make it look like these two things are correlating because they're messing with the axes. Cherry pick timeline, that's going to be most common in a line graph or a bar graph. Again, timeline of things is usually portrayed in a line or a bar graph. So whenever you're encountering one of these, always make sure that you have the idea of zooming out. And this is not always the case. It's going to depend on the specific graph or chart you're looking at. But it's always good to make sure that you're thinking about, is this timeline cherry picked? And then finally, what is the source? You're going to want to ask this question in all graphs, charts, and studies that you're presented with. Always good to have that in the back of your mind as well. So when you're encountering graphs, charts, and studies like this, first thing you should do is always look at the title of the graph or chart. So just like what does it actually say that they're trying to show you. Second thing is you're going to identify what type of graph it is. So is it a line graph, a bar chart, a pie graph, a dot plot? Whatever type of graph it is, make sure you know that. Third thing, you're going to look for a time or a timeline. So if it's a pie chart, it's usually just going to be a singular year. If it's a bar chart or a line graph, it's usually going to be a time on the x-axis. Sometimes it's on the y-axis, but it will be a timeline that's going continuously. And then finally, you're going to just look for any of those misleading tactics that we went over on the last slide. So let's do some examples here. And we're going to look at various graphs, and we're going to say, are they misleading or are they a good graph? We'll give them a thumbs up, not misleading. So here we have sales increases from 2003 to 2018. This is a bar graph, and let's look at this. So it looks like Chevy is absolutely dominating in sales increases from 2003 to 18. However, when we look at the y-axis here, you can see that this is a very zoomed in y-axis, and it doesn't start at 0. It starts at 95%. So it makes it look like Chevy has almost times 6 sales increase of Nissan, and at least doubled up Toyota, and probably about 30% on Ford. However, that's only because it's so zoomed in. This we're going to label misleading. So when you actually zoom out and get the bigger picture and start at 0 on the y-axis, this is what the real picture would look like. And as you can see, Chevy's not doing all that much better than any of the other 3 brands. Let's look at another one. Here we're looking at the number of COVID-19 cases in Russia from March 5th to March 31st. This is a bar graph. Our timeline, March 5th to March 31st. And that we can see that is charted with March 5th starting on the left to March 31st over there. And then we look at our y-axis here. It starts at 0 and it has a reasonable increment, so it's not too zoomed in. So we're good on the y-axis. So your instinct might be to say that this is cherry-picked because it's only about a month time period of data. However, in this case, when we have an exponentially growing thing and it's something like a virus that can spread very quickly, let's say that we're looking at this graph in April. Well, this actually would be very helpful in knowing what the potential prediction could be for what it will spread into April and May. And so when thinking about cherry-picked pieces of data, it depends on what you're looking at. Like this one, we're going to give a thumbs up because it is dealing with a virus and the spread and is moving very fast. However, when you're looking at stuff from sales and companies highlighting specific periods, stuff like that, you're really going to want to have to zoom out and look at the larger picture. Let's go to another example here. Poll shows that Olympic attendees' favorite country is China is the title. And so you can see 71% of correspondents said that China was their favorite country to host Olympics. And then you had second place was Brazil with 12%, US in third place with 9%, and South Korea at 8%. However, if we do a little bit more digging on what was actually surveyed here, and we also know this is a pie chart, we see that this is a favorite country is surveyed by only 200 people at the Beijing Olympics in 2008. So notice 2008, and again, it's only 200 people at the Beijing Olympics. So this is actually going to be a small and biased poll because 200 people is not enough people to be included to make any real conclusion from. And of course, if it's surveyed at Beijing, which is in China, most of the attendees probably will be from China. So there's going to be a lot of bias there. So this one we're going to label as misleading. What about this one? Money spent on pets in the U.S. and people who died by falling down the stairs. And you can see that this is a line graph comparing the two from 2000 to 2008. And you have money spent on pets over here on the left. And then on the right, the red is tracking the deaths by falling down the stairs. So neither of these axes start at 0, which means that they've tinkered with them a little bit to make this correlation look more linked than it really is. And we also know that these are two very unrelated topics. It's an implied correlation. These things we know realistically, when you think about it deeply, don't have any effect on each other. So we're going to label this as misleading. Let's go to this one. And this is looking at how 2012 stacks up, the warmest year on record in the contiguous US. So this is a bar graph. And there's some problems with this one right off the bat. It's going up to 2012. It starts from 1921 to 2012. However, it doesn't include every single year in there. We don't know how cherry picked these years are, and the y-axis does not start here at 0. It starts at 53 degrees to make it seem like 2012. The eyeball looks like it's way, way hotter than these other years, but it's really just a degree hotter. And it also doesn't show all the years in the time period. So the better thing to do would be to zoom out and look at every year in that time period and see which way it's trending. Is this an anomaly? Because it's really just not giving us as much as we need to see. So we're going to label this one as misleading. Let's go to the last one here. Gross domestic product of Japan. And gross domestic product is essentially the baseline measure of a country's economy. And we have 3 sections here. And it's from 1960 to 2024. So we have our section here, our section here, and our section here at the bottom. And all 3 follow the same timeline of 1960 to 2024. So if we look at this first section, this is measuring the total GDP in billions of US dollars. The second one is measuring the per capita or per person GDP in US dollars. And then the third one is just measuring the annual percentage change from year to year. So if you look at it, it's a good timeline. The axes all start at 0 and give us a very accurate picture. I wouldn't even say there's nothing misleading. This is actually a phenomenal graph and phenomenal data. And we're going to give this a thumbs up. We would give it 2 thumbs up if we could, but we only have one guy here. So that is a run through of misleading tactics and examples of both good graphs and bad graphs.